These are called mass problems. The reason why they're called mass problems is because we're starting in grams, we're going through a chemical reaction, and we're ending in grams. So let's perform a reaction that you've done this year. So earlier this year, you took some water, and it was a liquid, and you electrocuted it, and you made two gases. You were very excited about this. You discovered that when you went through this reaction that you made twice as much hydrogen as you did oxygen. So now, today, you can actually figure out, if we start with 100 grams of water, you can actually calculate exactly how many grams of hydrogen you're going to make. I'm going to show you how. It's a 3-step process. So you have to figure out what you have. So do you notice how I organized the equation? Do you notice how I wrote down what I had underneath it? You're going to need to do that, because these are easy problems. They get more difficult. Okay? And you're going to have to first change grams to moles. So whatever you have in grams, in this case we have water, so I'm going to change my grams of water to moles of water. This is my problem-solving process. Then I'm going to do my equivalent. And I'm going to use my balanced chemical equation. So I'm going to use my coefficients. And I'm going to go from moles of water to the moles of what I actually want to find out. And I want to find out how many moles of hydrogen that I make. I don't want my answer in moles because I can't count moles, right? We discovered last week we can't count moles. We have to convert it into grams or liters. So that's what I'm going to do. My last step is I'm going to change my moles into grams. So I have my moles of hydrogen, and I'm going to change that into grams of hydrogen, which I can put on the scale, and I can mass. So we have to get good at this, because the next thing I'm going to do is I'm going to hand you something, and you're going to run it through a chemical reaction. You're going to tell me, before you even run the chemical reaction, exactly how many grams of something you're going to make. That's where we're headed with this. So you'll develop a procedure, you'll collect data, you'll have a data table, you'll run your experiment, and then you'll see, oh, I made this many grams. Is that how much I was supposed to make? And then you'll calculate your percent error. So do you see where you're headed with this? Yes or no? Okay, so you get to do a lab. And it'll be pretty intense, depending on what chemical reaction we pick. Okay? So now, let's do this. So I have 100 grams of water. Now we're going to use the skills that we've learned over the last few weeks. I want to know how many moles of water that is. So if I'm going from grams to moles, what is my equivalent that I'm going to use? I know that how many grams of water is equivalent to 1 mole of water. Do you remember this? Yes or no? What number do I put right here? The molar mass of water. The molar mass is where I look at the periodic table, I list what I have, I write down how many I have, I look at the subscripts, so I have 2 hydrogens. I look at how heavy they are. I should say their mass, not heavy. I'm going to look at my periodic table, the one that you have all in front of you. And these are the numbers that come off of it, and then I'm going to add them together, and I get 18.02. Are you with me on that? Do you remember this? You were all good at this. You took a quiz on this last week, and most of you did really well. So you're using that skill here. So you're going to cross multiply and divide. So help me out here. Take 100 divided by 18.02. For me, somebody. Okay, I'll do it myself.
5.5.
Okay? So I have 5.55 moles of water. Okay, so that's how many moles of water I have. I'm working with 5.5 moles of water. I want to figure out how many moles. Where's my question mark at? H2. I want to figure out how many moles of H2 I have. So how am I going to do this equivalent over here? Where do I get the moles? What did we just get done learning on our Poggle? Where am I going to get these numbers at? Can you tell me? For my balanced chemical equation, the coefficients. So I have a 2 here, and then I have a 2 here. So how many moles of hydrogen am I going to come up with if I cross multiply and divide? Do you agree? Am I going too fast? Nobody's talking to me. I'm all alone in my chemistry. Okay. Do you understand? No? How can I help you? Can you specifically tell me where you got stuck? At number 1 or at number 2? Whoever said that, please just tell me.
Why do we have 2 moles of H2O?
This is the coefficient in front of the H2. Do you see that? So that is the reason why. For every 2 moles of this, I make 2 moles of this. Does that make sense? So these numbers come from the balanced chemical equation. That's what the coefficients are. If you remember our notes, not from yesterday, the day before, that's what I specifically taught you. So now we're using that skill. We're practicing it. We did our Poggle to discover why. Why do we use those? So now that we've finished that, you should understand why we use them and how we use them. Peyton?
So I thought on the chemical reaction we only had 1 chemical H2O. So why was it 2?
We have 2 because there's 2 H's here. 2 times 2 is 4. We have 2 times 2 is 4. I need 4 H's on this side and I need 4 H's on this side. Does that make sense? Okay, now I need to go into my great questions. And now I need to go into my final step. I'm going from grams to from moles to grams. Why would I want to go from moles to grams? What do we know about moles? You can't, yeah, you can't count them. But I can put grams on a scale, so I'm going to do that. And I know that 1 mole of H2 is equivalent to how many grams of H2? Do you remember what we put here when we do our equivalents for mass mole? We use the molar mass. So do you see how all the skills that you've been learning the last 3 weeks, we pieced them out? We looked at each skill individually and learned each skill, and now we're putting them together in a big thing. So it's kind of like a basketball play. You break the play down into skills, and then you put all the skills into it, and you get a play. So I'm going to cross multiply and divide here. I'm going to need the molar mass of H2. So you're going to take 5.55 times 2.02. Yes?
I thought that the molar mass of H2 would be 1.008 times 2. Why is it 1.008 times 2?
If you have your sheet, we're going to round to 2 decimal points. We agreed on that. And this is 1.008, so that 8's going to round the 0 to a 1. So I'm going to use 1.01 if I'm rounding to 2 decimal points, because you guys said that you all wanted to get the same answers as me. So if we want to get the same answers, then we need to round to 2 decimal points. We agreed to that. That was our class agreement. I'm okay with not getting the same answers. Others are not okay.
I was just wondering.
That's a great question. Okay, what do we get? Help me out here. 11.21. There you go. That's exactly how many grams of hydrogen you'll have in your test tube. That's quite a lot, by the way, because hydrogen's pretty light. Do you remember how many liters 1 mole is? Do you remember we just went through that? 1 mole is 22.4 liters. And you have how many moles? You have 5. So that's going to be a huge amount of hydrogen. And hydrogen's explosive. Yikes. Okay. So this is how you're going to do these problems. How are you going to feel about these problems? Not good, but you have to start someplace. Okay? ChatGPT can't do stoichiometry problems. By the way, that's what you're doing. This is called stoichiometry. Stoichiometry is a Latin word for story problem. But these are much bigger than story problems. Notice I haven't given you any story problems. These are problems you're going to have to figure out, right? Because remember, your original driving question for this unit was, do amounts matter? And do you remember the reaction that I gave you? Remember how it all of a sudden turned black and then the other ones were different? What do you think I did differently in those? I put a different amount in them. Okay? So do these 3 problems, trying, not crying. And since we created them ourselves, they're not going to be on the internet.